So the last two lessons, on Monday this week, we did the 30, 60, 90. And then on Wednesday last week, we did the 45, 45, 90. And so now we're going to use those triangles to construct what's called a unit circle today. Now, so let's kind of review what we did these past two lessons. So remember that in a 45, 45, 90 triangle, which is here, remember if you know the side, all you have to do is just multiply by √2 to get the other side, right? So for example, let's look at the first problem here. If this is a 45, 45, 90 triangle, I know that the two sides are the same, right? So V has to be 9, and then U has to be 9√2, because that's the relationship they have, right? And we talked about that last week. In a 45, 45, 90 triangle, the two sides are the same. So if this is 9, that has to be 9. And then the hypotenuse, you just multiply by √2. That was the easy problem. But remember, we also had this problem, where if they gave us the hypotenuse was 6, how do we go back to the leg? Well, remember, if I multiply by √2 to get to the hypotenuse, if you have the hypotenuse and you want to get to the leg, you do the opposite, which is divide. So if you remember from last week, what we did was to get to the leg, we divide by √2. Now, remember, we do not want a radical on the bottom, so we multiply both sides, both the top and bottom, by radical 2. And so this becomes 6 radical 2 over 2. Remember that radical 2 times radical 2 is just radical 4, and so that simplifies to 2. And then so you get your two legs here. If you simplify that, (3√2). So that was last Wednesday's lesson, right? If you want to get to the hypotenuse, you multiply by √2. If you have the hypotenuse and you want to get the leg, you divide by √2. So let's look at this triangle here. So I have a 45, 45, and 90, and they tell me the hypotenuse is 1. So how do we go back to the leg? Well, we do the same thing we did in this middle problem. If they give you the hypotenuse and you want to go to the leg, you just divide by √2. Okay. And once again, we do not want that radical on the bottom. So whenever there's a radical on the bottom, you multiply by that radical, numerator and denominator. And then this ends up being √2 over 2. So that means both of the legs are √2 over 2. Because it's a 45, 45, 90, the two legs are the same. Okay, so that's the review of the 45, 45, 90. Now we're going to do a quick review of what we did Monday. Look up here. This is the 30, 60, 90 triangle. And here's the relationship. If you know the short leg, you just multiply it by √3 to get the long leg. And then if you know the short leg, you just multiply it by 2 to get the hypotenuse. So for example, let's look at the first 30, 60, 90 triangle here. If the short leg is 5, this is really simple. The long leg is just, you multiply it by √3. And then the hypotenuse, you multiply the short leg by 2. So 5 times 2 is 10. Okay. But now let's look at if they give you the hypotenuse instead. So remember the relationship here, that the leg is half the hypotenuse. So here, if 16 is the hypotenuse, the leg, the y, the short leg, is simply 8, right? It's half of 16. And then x, you just multiply the short leg by root 3, 8 root 3. So that's what we did on Monday. If you missed the video on Monday, you just have to realize that these were the real triangles from geometry that you learned, and they have this special relationship. So let's go here. Going back, and now let's say the hypotenuse is 1, right? I know that the short leg has to be half of 1. Well, what's half of 1? That's easy, it's just 1/2. And then remember, how do I get the long leg? You multiply the short leg by root 3. So 1/2 times root 3 is root 3 over 2. Okay. So let's look at this triangle here. This is actually the same as this triangle. It's just kind of like shifted around, right? So we're going to have the same measurements, except this side will be 1/2, and this will be root 3 over 2. But now 30 degrees is the angle over here, while this is 60. Okay. So that was just a review. We're going to use these triangles for actually what the topic is today. Now, the topic for today is called the unit circle. And the unit circle is, so let's say you had like a grid here. A unit circle is basically a circle with the center is 0, 0, and the radius is 1. So it doesn't matter where you draw your radius, the radius will always be 1. That's a unit circle, right? And of course, that's the definition of the circle. The radius has to be the same, right? So a unit circle is a circle. If I draw it on an XY grid, the center is 0, 0, and its radius is 1. Okay. Now let's think about this unit circle for a bit. I know that if the radius is 1, and let me draw this circle again. So if the radius is 1, then I know this point here has to be 1, 0, right? Like the way that you would label a point. Because if it goes out here, then it's 1, 0. So on this big unit circle, I'm going to put here that this is 1, 0. Now, this point up here, well, this is the point 0, 1, right? Because if this point here is 0, 0, if the radius is 1, then going up there is 0, 1. Then the point on the left is negative 1, 0. And then the point all the way on the bottom would be 0, negative 1. right? Everyone okay with those 4 points? How I got those 4 points? Where those 4 points came from? Okay. Now we're going to move on. Whoops. Because we're going to fill out this whole circle. So what I'm going to do is I am going to use these triangles that we have here. And why am I going to use these triangles? Well, remember, the radius is equal to 1. So here, I could say that this is, I'm going to use a different color here. So you see what I'm drawing in the green right here? This is a 30-degree angle. And then what I'm going to do is I'm going to make a right triangle. Well, I know if this is a 30 and 60, right? And since this is a unit circle, I know my hypotenuse is 1. But guess what we did already? Look what we did here. We actually made this triangle already. If the hypotenuse is 1, I know this side is 1/2, and I know this side is √3/2. So does everyone see what we did? We took this triangle that we made here, and we just put it into this circle. And so I know that this point here, the one that I'm filling in right there, I know the coordinate for that point has to be √3/2, 1/2. Okay, I'm going to stop there. What questions do you have for me right now? Or does everyone see where why this is X and this is Y? Because remember, on a coordinate grid, going to the right is X and going up is Y. That's why this is X and that's why the 1/2 is the Y. That's where I think that's probably the one of the questions you might have is that, remember, this is just a regular XY coordinate system. So if I go to the right, that's X, so that's why this is first, and then this is the Y value, so that's why I'm using the 1/2. So I'm going to move on to the next angle. There's going to be a lot of, after I do a couple, you'll see what's going on here. So what I'm going to do on the unit circle is I'm going to label this as 30 degrees. Because that was when this angle here was 30 degrees, right? Now, now I'm going to go to the next line. And this line is actually going to be a 45-degree angle. Well, what I'm going to do is I'm going to do the same thing I did with my 30-degree angle. I'm going to make a right triangle. And so what I made was I just made a 45, 45, 90 triangle. And remember, since this is a unit circle, the radius is 1. So that means my hypotenuse is 1. So guess what we did? We already made this triangle. It's right here. This is the 45, 45, 90 triangle where the hypotenuse is 1. So that means the x value here is root 2 over 2, and the y value here is root 2 over 2. So that means this point right here, the x is root 2 over 2, and the y is root 2 over 2. Okay. And since that was a 45-degree angle, I am going to label this 45 degrees. Okay, now I'm going to use a different color and go with this line. So same idea, I'm going to make a triangle here. This angle this time is 60. And then so if I make my right triangle, it's a 30, 60, 90 triangle again. So we're going to take the 30, 60, 90 triangle we made up here, which we already did. Across the 60 is root 3 over 2, and across the 30 is 1/2. So this point here is 1/2 root 3 over 2. Because the x is 1/2 and the y is root 3 over 2. So before we move on, and so this was a 60-degree angle. So what I'm going to say is this is 60 degrees. Now, before we move on to some of these other lines, let me explain this circle a little more. So as you can see, the way the angles are going is it's increasing as we're going to counterclockwise, right? So actually, if you're right here, this is the start of it. This is actually 0 degrees right here. Whoops, 0 degrees. However, I think all of you know that one full circle is also 360 degrees. So we actually, and let me change this a bit. We start at 0 degrees, and then if we go all the way around a circle, most of you should know that a full circle is 360 degrees. So whenever you see a unit circle, we always start here on the right at 0 degrees, and we go around until we come back to 360, right? And so you should know from geometry, or for those of you that snowboard, skateboard, some of these angle measures, right? You should know that 90 degrees is the right angle. So I'm going to put 90 here. You know that 180 is half a turn. So 180 is over here. You should also know that this is 270 because it's 3/4 of a turn. And then a full circle is 360. Okay. So 0, 30, 45, 60, 90, 180, 270. Now there's a bunch of these other lines here. And trust me, it's once you get this top right, all the other ones are going to be the same exact thing. Let me show you why. So As you can see, the lines are in the same place in every single section of the circle. So that means, see how this is 30 degrees? This angle here is 30 degrees. I'm going to draw it for you. So you see how this angle was 30? This angle is also 30. This angle is 30. And this angle is 30. They all form an angle of 30 degrees with the x-axis. I know there's a lot of new stuff going on. And so if you have any questions, let me know. And if you guys see, this is a 45-degree angle. This is also a 45-degree angle. This is a 45-degree angle. And this is a 45-degree angle. And then lastly, you'll see that this is a 60-degree angle. This is 60 degrees. This is 60. And that's 60. They're all 60 degrees, right? So what's going to happen is let's actually figure out what all of these angles are. So remember how I said give me a second. So you see how these were all 30 degrees? Okay. So that means if this is 180 and you're going 30 degrees back, this should be 150 and this should be 210. By the way, if you guys were an actual class, like in, if we still had in-person class, one of the quizzes we take is a memorization quiz on this circle. So you guys kind of lucked out that you don't have to take it because you can't take it online because you could just have it on the side and copy it. So, but this is something that we have you memorize. And also for those of you that are going on to trig, this is something you need to memorize. So these are all 30-degree angles. And so if this is 360, then this has to be 330. Okay. Everyone see how we got these angle measures? If these are all 30 degrees, and I know this is 180, if you go 30 degrees back, it's 150. 30 degrees forward, it's 210. If this is 360, you just go 30 degrees back, and that's 330. Now, the next angle that we had was, we said all of these were 45-degree angles, right? So if we just go ahead and you could use a calculator or something, if this is 180 and I go 45 degrees back, or if this is, so this would just be 135, okay? If this is 180 and I go 45 degrees forward, this is 225. And then if this is 360 right here and I go 45 degrees back, this is 315. And then the last angle that we have is, I know that these are all 60-degree angles. I talked about this before. And so we could fill out the rest of the unit circle. If this is 180, and this is a 60-degree angle, we just subtract 60 from 180. This is 120. 180, and we add 60 here. This is 240. And then if we go all the way here and we get 360 and we subtract 60, this is 300. Okay. So all of those degree measures are the important degree measures for the unit circle. But you should all see a pattern here, right? These are 30-degree angles away from the 180 and 360. These are the 45-degree angles, and these are the 60-degree angles. Okay. Okay, so what we need to finish now is see how I found coordinates for these? I'm going to find coordinates for the rest of them. But I want you guys to look what I did here. So remember what I did here with the 30-degree angle? If this was 30, right? I know, going back here, that the x is √3/2 and the y is 1/2. Yeah? But look what happens here. I could also draw a 30-degree angle here. If this is 30, this is also 1/2 and √3/2. So what would my coordinates be right here? Well, since I'm going to the left with x, it's negative √3/2, positive 1/2. So I hope you guys got that. Look at my right, what I wrote in green, and look at my left that I wrote in green. See how it's the same numbers? Because I'm still using the same 30, 60, 90 triangle. My x is still √3/2 and my y is still 1/2. Except remember, on a coordinate grid, if you go to the left from 0, 0, x is negative. So look what we could keep doing here. If I draw my 30-degree angle here, my x is still √3/2 and my y is also 1/2. So my coordinates here would be negative √3/2, negative 1/2. You see that I'm using the same x and y value for all of these triangles, except the signs are changing based on where I am located. And then if I draw another 30, 60, 90 triangle here, right, you'll see that this is still 1/2 and the x is still √3/2, except now since I'm on the bottom right, my x is positive and my y is negative. But you see how it's the same numbers, except the signs change based on where you are. Is anyone confused on the signs? Just the signs. If you're confused on something else, we have to go back a little bit, but just the signs, because I wanted to clear that up. Is anyone confused of how you know which is positive and which is negative? Okay. No one said anything. I think we're going to move on. Okay, so I'm going to erase all the green on the inside because we're going to be doing a different color now. Okay, now I'm going to move on to the blue. So remember that these were all 45, 90 triangles. And remember how using the triangle from up here, my x and my y were √2/2 and √2/2. So this was √2/2, √2/2. So guess what? If we do the 45, 45, 90 here, this is √2/2, this is √2/2, right? So that means the coordinate here would be that. It has the same x and y as the 45 degrees on the right, except since I'm going to the left, x is negative. And then if I draw a 45, 45, 90, here, this is √2/2, this is √2/2, the x. So I still have the same x and the same y, except now it's on the bottom left, so it's going left and going down, so it's negative √2/2, negative √2/2. And then same thing here, if I draw my 45-degree angle here, right? This would still be the same x and y. But now that we're going to the bottom right, my x is positive, my y is negative. Okay, now I'm going to erase all my blue and we'll do the purple. Okay, so if we do the purple, we have this triangle. And we established before that if this is 60 down here, right? This is √3/2, and this is 1/2, right? And that's where we got the 1/2 √3/2. So once again, if I draw the 60-degree angles, everywhere, I still have the same x and the same y. But remember, going to the left first means that this point is negative 1/2 √3/2. If I draw a 60-degree angle here, that's 1/2, this is √3/2. And so since we're on the bottom left, this is negative 1/2, negative √3/2. And then obviously if I do this, it would be, the y value would be √3/2. And so this is 1/2 negative √3/2. Okay, and we did it. We completed what's called the unit circle. This is the basis of all trig here. Okay. Yeah, the whole topic of trigonometry is based on this one circle. And so that's why we would have you memorize this if we were in class. This whole thing. So right now, if you're not taking notes on the actual notes and you were just like watching, I would take a picture of this right now because this is the complete unit circle. Okay. Now, these coordinates are the, so what this coordinate means, root 3 over 2, 1/2, that's the xy coordinate of this section right here. Root 2 over 2, root 2 over 2 is the xy coordinate of this point that's right here where my cursor is. 1/2 root 3 over 2 is this point right here. 0, 1 is this point right here. Negative 1/2 root 3 over 2 is this point right here. Okay? Now, one more thing. You see how we divide the circle into 4 quadrants? It's called 4 quadrants. We divide the circle into 4 quadrants. We actually have a naming, we name the quadrants different numbers, and we use Roman numerals here. So we start, see how we start here, and then we go counterclockwise? So that's how we number them. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay? 1, 2, 3, 4. Well, maybe you want to take a picture of that now because it has the quadrant numbers on there. Okay? But I hope you kind of get the picture here. You really only have to memorize the top right because guess what? Look at all the green. It's the same numbers. It's just that the signs change based where you are. Look at all the blue. Same numbers, except if you're on the top left, x is negative. If you're on the bottom left, x and y are negative. And then on the bottom right, x is positive, y is negative. And look at all the purple. All the same numbers, except the signs change based where you're at. So I know that took a long time to derive, but the problems for this are actually really easy. Your homework is going to be super easy. Let's look at some of the homework problems you're going to have. And you'll be like, oh, that's it? Yes, we just had to establish this long thing. But this is how your homework is going to look like, the first part. What are the coordinates on the unit circle for the following angles? What quadrant does the angle lie in? So I want everyone to pay attention now because this is your homework. So it says 135 degrees. So all you have to do is just go to your unit circle, find 135, and all you do is you just name the coordinate that goes along with 135 degrees. That's it. So you see 135 is negative root 2 over 2, root 2 over 2. So that's all I'm going to write. And then the second question is what quadrant does the angle lie in? 135 is right here. That is quadrant 2. Okay. After all that, you see how easy this is? So the second one, what coordinates on the unit circle for 90 degrees? 90 degrees is up here. What are the coordinates? 0, 1. Now, what quadrant does the angle lie in? Look where 90 is. It's right in the middle of 1 and 2, so it actually has no quadrant. If you're anywhere on the sides here, if you're at 0, 90, 180, 270, or 360, you don't have a quadrant. Okay. Now 30 degrees, 30, you just find 30 on your circle, and right here is your coordinate, root 3 over 2, 1/2. And 30 degrees is in quadrant 1. Okay, next question. 300 degrees. Actually, you do the last two on your own. Should be really simple. So letter D, 300 degrees is right here. So the coordinate is 1/2 negative root 3 over 2. And it's in quadrant 4. And then 225 is right here on the bottom left. So you go and you find its quadrant. You find its coordinate, negative root 2 over 2, negative root 2 over 2. And then it is in quadrant 3. Okay? Any questions on that? That should be super simple. Okay? Now, last thing, and this is also kind of fairly simple. So I'm going to copy the triangles that we had here. So the 45, 45, 90 triangle, remember how it was root 2 over 2, root 2 over 2? So here, okay. Now, the 30-degree angle, so this is 30. The y is 1/2, and the x is root 3 over 2. That's a 3. And then the 60-degree angle is the same as the 30-degree angle, it's just reversed. So remember 60, the root 3 over 2 is the y, the x is the 1/2. Now, one of the things we also reviewed was, remember we did now let's look what happens if we use Sohcahtoa here. So if we were using the unit circle, remember the unit circle, the radius is always 1, right? That's why the hypotenuse for all of these was always 1. So if I do sine of 45, sine of 45 is opposite over hypotenuse. So if this is 45, the opposite is root 2 over 2, and the hypotenuse is 1. Well, what happens if you divide by 1? It's just the same thing. So cosine of 45 is adjacent over hypotenuse. So if this is 45, the adjacent is root 2 over 2, and the hypotenuse is 1. But what happens when you divide by 1? It's just root 2 over 2. Same thing here. If I take the sine of 30, it's opposite over hypotenuse. What's the opposite for the 30? It's 1/2. And when you divide by 1, it's just 1/2. Cosine, once again, is adjacent over the hypotenuse. So the adjacent is root 3 over 2, and I divide by 1, that's still root 3 over 2. And then same thing happens here, and I think you kind of get the picture why we're doing this, is because our hypotenuse is always going to be, for a unit circle, 1. And then this is 1/2 over 1, which is 1/2. So what we did there was we just used our Sohcahtoa, right? Sine is opposite over hypotenuse, opposite over hypotenuse, opposite over hypotenuse. Cosine was adjacent over hypotenuse, adjacent over hypotenuse, adjacent over hypotenuse. However, what you see here is that the hypotenuse was always hypotenuse is always 1, which means look at the sine. Sine is going to be y over 1. For 30 degrees, it's y over 1. 60 degrees, it's the y value over 1. And whenever you divide by 1, the sine will stay whatever the y value is. So, in the unit circle, and this will all make sense in a bit. The sine, and if you haven't been attending these classes, that was the theta just means angle, but the sine in a unit circle is just the y value, because the opposite is the y. The hypotenuse is always 1. So when you use opposite over hypotenuse, hypotenuse is 1. So that's why the sine value is just the y value. And then cosine is just the x. Because cosine's usually adjacent over hypotenuse. However, the hypotenuse for a unit circle is always 1, and the adjacent is always the x, so that's why it's going to be x. So, last thing before we go. These are going to be the last part of your homework. And all you have to do now, and I want everyone to pay attention here, sine of 135 means what is the y value at 135. So all you have to do is go back to your unit circle, find 135, and see how there's a coordinate point, negative root 2 over 2, root 2 over 2. Sine is just the y value. So I'm just going to pick root 2 over 2. That's how easy this is. Next problem is cosine of 150. Cosine is just x on a unit circle. So I'm going to go back to my unit circle. I'm going to find 150. I see the point here. It's x and y. Since I'm looking for cosine, I just have to put the x value. And that's negative root 3 over 2. So sine of 330. Once again, you go to your unit circle, you go to where you see 330, and since I'm looking for sine, sine is y, so I just choose the negative 1/2. So you see how easy this is? I know that a majority of the time spent on today was deriving that unit circle, but once you have it, these problems are fairly simple. So cosine of 180, so cosine once again is x. So you go to your unit circle, you find 180, there's the point here, so you're just looking for the x, which is negative 1. And then so on and so on. I don't think I need to go through all of these, but just one more time. Letter E, cosine of 240. Cosine is x, so I just go to 240. This is the coordinate for 240, and I just have to pick the x value. And so that is negative 1/2. Okay? Anyone have any questions before we go? By the way, everyone, I want to show you how easy the homework is today. Right here. Number 1, what are the coordinates for the following angles? We just did, you just find the angle, write the point, and then write the quadrant. And then number 2, you just find me the sine and cosine. Remember, sine is y, cosine is x. Find the angles and put the coordinate. And that's it. That's all the homework is today. This should take you 10 minutes at the most, right? So don't wait until tomorrow to do it. Do it now. Turn it in. Okay, lastly, does anyone have any questions? I'll leave it on here just in case you need to take a picture of this. You could also just Google unit circle and just select images, and you'll see a bunch of filled in unit circles. Yes, Andrea, I am going to post this. Okay. Anyone else have any